Hello everyone, I am Dinesh, and over the semester I have been working on developing a class scheduling application based on genetic algorithms. What is class scheduling problem? As the name suggests, the class scheduling problem is a problem to schedule classes in an educational organization given some constraints like classroom capacity or available professors. The problem tries to distribute the classes optimally given the set of classrooms, number of students, classroom equipments, professors, etc. Scheduling problem is a constant satisfaction problem, which in turn is NP-complete. Usually there are two types of constraints, hard and soft constraints. Hard constraints are the constraints that cannot be avoided, as if avoided, the problem cannot be solved further. For example, a class can be scheduled only in an empty classroom. Soft constraints are the constraints that should ideally not be avoided, but can be ignored without making the scheduling impossible. For example, students or professors don't want to have a class at a specific time of the day. Let's say in the late evenings or late mornings. Being a classical scheduling NP-complete problem, there are many solutions that have been proposed to solve the class scheduling problem based on multiple algorithms like simulating annealing, neural networks, advanced ILP techniques, dynamic and linear programming, genetic algorithms, and list goes on and on. Based on biological inspired operations like mutation, selection, and crossover, genetic algorithms can generate near-perfect solutions to search and optimization problems. A genetic algorithm requires genetic representation of the solution domain and a fitness function to check the fitness or evaluation of the solution domain. You can look at my project paper or go over genetic algorithm research papers and articles for more details, as describing genetic algorithm in details here would make this presentation very long. The main challenge in applying genetic algorithm is to come up with a representation of schedule, computing fitness value, doing a crossover, and performing mutations. I've discussed my approach of this representation in my project paper in detail. Basically, we will store all the relevant information about a schedule in a single vector, which will be our chromosome. The idea here is to create a function that increases when schedule become more correct. One way to do it is to give penalty for things that are bad in the schedule. For example, a class is placed into already occupied room. There are 5 hard requirements that need to be satisfied for each schedule. Number 1. A class is placed in an empty room. 2. A group cannot have multiple classes at the same time. 3. A professor cannot have multiple classes at the same time. 4. A class should have enough free seats in it. 5. Room should have computers or lab equipments if class is needed. Crossover operator in my algorithm is a way to combine two schedules to get hopefully a better one. Mutation is another operation in the algorithm. We'll just move constant number of course classes to other slots. For detailed work, please take a look at the project paper. I have written the genetic algorithm in C++, and the graphical user interface is built using Qt Creator's Community Edition. Please take a look at the application demo. This is how the main graphical user interface looks like. As you can see, there are a number of parameters to specify. Number of schedules to try. This is the population size, that is how many schedules do we keep in every iteration. Modification size. Number of slots to move in the mutation. Probability of modification. That shows the ratio of schedules that are going to be mutated. Ratio of schedules to keep. Using this function, we won't delete specific ratios of best schedules found so far. First, we need the configuration file. The configuration file contains the professor's class, courses, and group details, etc. In this project, we create a schedule for each professor. We can select the professor from the drop-down menu on the top. Let me load the configuration file first. So here the list of professors that we want to schedule the classes for. Once we click the start button, the genetic algorithm executes and does the scheduling for the professors. Current iterations and fitness of the schedule are on the bottom. We can stop iterations whenever we want, maybe when fitness doesn't increase. Each class is shown as a rectangle containing course name, classes that take it, and classroom. Also on the bottom you see a group of green words. FR means whether the room is free or not. LB whether it has computers or lab if needed. ST whether it has enough seats. OL whether this group has other classes at the same time. PF, whether professors has another lecture at the same time. When some constraint is violated, it would have a red color as shown above. Let's take the example of Professor Declan. The class Introduction to Programming on Monday cannot be scheduled as the class lacks lab equipment, shown by the code LB. It also lacks sitting space, that is code ST, and is not even available, shown by the code FR. However, the same class can be scheduled on Thursday at 9 to 11 a.m. with student group IS1 and in room R3, as none of the constraints have been violated. Future work. The algorithm is not perfect. The efficiency and robustness of the algorithm hugely depends upon the number of hard and soft requirements of an organization. So another future branch would be to work on creating a free-to-use web service accessible over internet, and a repository of constraints can be created by getting the requirements from different organizations. Thank you. Have a good day.